Your phone can recognize your face. Self-driving cars can spot pedestrians. All of it traces back to one woman, and she wasn't even supposed to be in the room. Here's what most people don't realize about AI. Everyone thinks the breakthrough was about brilliant algorithms, smarter code, faster processors. The truth is much stranger. For decades, computers couldn't recognize basic objects: a cat, a chair, a car. The world's best researchers at the world's best universities kept building better algorithms, and the machines kept failing. They look at a photograph of a dog and say truck. They'd see a coffee mug and call it a tree. It was embarrassing. And the weird part, almost nobody understood why. Then an outsider figured it out. Someone who'd spent her teenage years scrubbing floors and running a cash register. Someone who had never been part of the AI establishment. She saw what the Ivy League researchers missed. And to understand how she saw what others couldn't, you have to understand where she came from. Fei-Fei Li arrived in America at the age of 16 years old. Her family settled in Parsippany, New Jersey, and she spoke almost no English. Her father, who had been a respected engineer in China, now repaired cameras in a small shop. Her mother worked at the checkout counter at a supermarket, and Fei-Fei, she cleaned houses. She washed dishes at Chinese restaurants. And every class felt impossible. She later said, to an ESL student, every class is an English class. Math, history, science, it didn't matter. She was drowning in a language she could not understand. But here's where the story takes its first unexpected turn. Her math teacher, a man named Bob Sabella, saw something in her. He started teaching her calculus during his lunch breaks, for free, no extra pay. Just a teacher who believed in a struggling student. And that student, she got into Princeton. The acceptance letter came and she thought it was a mistake. She actually asked 2 different advisors to verify it was real. But getting to Princeton was one thing and surviving was another. She was living in 2 worlds. There was the Ivy League with its manicured lawns and brilliant classmates, and there was real life, where she worried constantly about her mother's health, about their finances, about being an outsider who didn't belong. Then she did something remarkable. She borrowed money, including from the Sabella family, and bought a dry cleaning business for her parents. Not invested in, bought. And for the next 7 years, through her undergraduate degree in Princeton and her PhD at Caltech, she ran that shop. She said, I joke I was a CEO. Picture that, a Princeton student, then a Caltech PhD candidate, spending weekends managing inventory, handling customers, and keeping the books. That duality, the living between 2 completely different worlds, would eventually change how she saw AI's biggest problem. By 2006, Li finished her PhD and became an assistant professor. She was officially inside the AI establishment now, and she could see what was broken. Everyone was obsessed with algorithms. Build a smarter neural network, write cleverer code. That's how you make machines see. Well, that was the conventional wisdom at least. But Li saw something different. She thought about how humans learn to see. A child doesn't learn what a cat looks like from 5 examples or 50. They see thousands of cats, tens of thousands, in different poses, different lighting, different contexts. By the time a kid is 3, they've processed millions of images. AI systems, they'd see maybe a few hundred examples per category. She wanted to create what she called a map of the entire world of objects. 14 million images, over 20,000 categories, every type of thing a machine might need to recognize. But when she told her colleagues, they thought she'd lost her mind. Mentors warned her this would end her career. An untenured professor betting everything on a data project when the whole field was obsessed with algorithms? That's not how you get tenured, that's how you get forgotten. At academic conferences, critics stood up and publicly challenged her. This is completely wrong, they'd say. We should solve one object at a time, but she ignored them. But then she hit a wall that almost stopped her for good. The math was impossible. Humans can classify about 2 images per second if they're focused. At that rate, labeling 14 million images would take 19 years of continuous work. And hiring undergrads at $10 an hour? Financially impossible. She sat with those numbers for weeks, 19 years. The project was dead before it started. Then she found something that changed everything. Amazon had a service called Mechanical Turk. You could post tiny tasks, pay workers pennies per task, and distribute the work globally. Anyone with an internet connection could participate. So between 2008 and 2010, 49,000 workers from 167 countries labeled her images. They worked through over a billion candidate images. Each image got labeled 3 times to ensure accuracy. Workers identified 50 images per minute. Think about that. The most important data set in AI history, the foundation of every image recognizing system used today, was built by tens of thousands of strangers clicking on pictures of cats and dogs and chairs for pennies. And when ImageNet was finally complete, she presented it at the field's biggest conference. It was a poster stuck in a corner. The response was muted. 3 years of work, 50,000 contributors, and 14 million images. And hardly anyone cared. She thought she'd done the impossible, but almost nobody noticed. Well, not yet. Then came September 2012. A team from the University of Toronto entered the ImageNet Challenge that year. Jeffrey, Alex, and Leah. They had something different. A deep neural network trained on Lee's massive dataset running on graphics processing units, and the results weren't close. Their system, called AlexNet, achieved a 15.3% error rate, and the second place finisher, 26.2%. It was a massacre. Lee later said 3 fundamental elements of modern AI converged for the first time: neural networks, massive data, and GPU computing. The critics had said she was wrong. The data said otherwise. Within years, the field transformed. By 2017, winning systems were achieving over 97% accuracy, better than humans, and every single one of them was trained on ImageNet. So today, when your phone unlocks by recognizing your face, ImageNet. When a self-driving car identifies a pedestrian, ImageNet. When a doctor uses AI to spot tumors in medical scans, ImageNet. And Lee went on to direct the Stanford AI Lab. She became chief scientist at Google Cloud. Time magazine named her one of the 100 most influential people in AI. Her company, World Labs, hit $1 billion valuation in 4 months. And in 2025, King Charles III named her the Queen Elizabeth Prize for Engineering, one of the highest honors in the field. Here's what changed how I see the whole story. The AI revolution wasn't built by lone geniuses perfecting algorithms in isolated labs. It was built by an immigrant who saw what insiders missed, and 50,000 strangers who taught machines to see, one click at a time. Remember that teenager cleaning houses in New Jersey? She's now standing alongside the pioneers of AI, Hinton, Leekun, Bengio, receiving engineers' highest honor, not because she built the smartest algorithm, but because she saw what everyone else missed. If there's one lesson here, it's this. The biggest breakthroughs don't always come from smarter technology. Sometimes they come from someone willing to ask a different question. If this story changed how you see AI, hit subscribe. We've got more coming.